dark openings could essentially be one of the most beguiling and baffling peculiarities in the universe. They are gigantic monsters concerning energy, yet at the same time, they are positively undetectable to us. A dark opening, weighing possibly 2 to 4 times the mass of the Sun, may appear far off. However, due to the research placed into them over the last few decades, we've gone from knowing positively nothing about them to getting to dissect them more closely. While things have just gotten more insane, Kaku recently presented that we finally got a glance at what is inside a dark opening. This new data sheds light on the subtleties that the universe of science might have overlooked from the beginning. Join us as we dig deeper into dark openings and reveal what is inside. Space is tremendous, but before we get into what Kaku found, we should discuss the basics. Despite the fact that most people have some idea of what dark openings are, there are still a few gaps in our understanding. In 1916, Albert Einstein published his theory of general relativity, which predicted the existence of dark openings. At that time, the possibility of dark openings was purely theoretical. It took an additional 50 years for the scientific community to find evidence that dark openings truly exist. This occurred during the 1960s when they were dissecting the Cygnus constellation and saw a strangely distinctive blue star emitting X-rays. This star was not a static object but was orbiting a massive dark object. Upon further examination, it was seen that the X-rays were not just moving on their own but were being sucked into the dark object they were orbiting. Thus, it was named Cygnus X1. This revelation was significant because it provided evidence that dark openings indeed exist and were not just a figment of Albert Einstein's wild imagination. While that was great, it also meant that there was this stunning substance in space that we urgently needed to know more about. So, analysts worldwide set to work. Cygnus X1 is located within the constellation Cygnus, about 6,000 light-years from Earth, and it was no small discovery. It is many times brighter than the Sun and immensely dense, giving it an extraordinarily strong gravitational force. The gravitational pull is so strong that not even light can escape it, hence the name dark opening. The concept of a dark opening is both intriguing and terrifying. It's a place in space where gravity is so strong that nothing, not even light, can escape. Whatever gets too close to a dark opening can be pulled into it, never to be seen again. However, this place of danger makes it all the more essential to study everything there is to know about them. Was this the end of our knowledge, or were we just beginning? The answer turned out to be the latter. After the discovery of Cygnus X1, scientists began to search for other dark openings. They found that there might be nearly 100 million dark openings in the Milky Way alone, but because they are so extraordinarily difficult to detect, we still don't have an exact number. Despite this, there are likely millions of dark openings in the Milky Way galaxy alone, making them essential to observe. So let's break it down. The primary subject with dark openings is always going to be gravity. Their gravitational pull is so intense that anything entering it is compressed cosmically until it becomes a singularity. In simpler terms, dark openings are like enormous vacuum cleaners that suck everything in. One of the scariest aspects of the research into dark openings is that if someone were to fall into one, they would be stretched to the point of becoming a single line. This process would happen slowly, and the person would die before the final form truly sets in. So, let's just say that no one should be getting too close to one. Yet they are everywhere. So, could we be in danger? Even though the nearest dark opening to Earth is 500 to 1,000 light-years away, it's still close enough to raise questions and concerns. In 2021, researchers were able to capture the first clear picture of a dark opening, specifically the M87 dark opening. This dark opening was photographed over several nights, and with each photo, the researchers gathered more and more evidence about it. They had to line the individual photos together to fill in all the gaps. In this way, they were able to determine that there are 3 layers to a dark opening. It's not just one single expanding void as many people believe. Things are much more complicated than that. To even get to the nothingness part of a dark opening, you have to pass through the first 2 layers. The first layer is known as the event horizon. Once inside, there's no turning back. You will be sucked into the dark opening. It only gets worse from there. The second layer is the photon sphere, which is the region where light orbits the dark opening. Any light that enters this area can be trapped and unable to escape. Eventually, we come to the third layer, which is the singularity. This is where everything entering the dark opening is compressed cosmically until it becomes a singularity. The singularity is a point in spacetime where the laws of physics, as we know them, break down, and we simply cannot predict what happens next. What makes this all the more terrifying is the fact that every dark opening you study will be completely different from the last. Sure, they do tend to follow the same three-layer concept, but the way they function can be vastly different. Now, if this were something else, all we would have to do is focus on those telescopes and study the main thing in detail. However, with dark openings, you can't actually do that. Scientists can study dark openings indirectly by observing the radiation they emit and the gas and dust that surrounds them. Sending a probe, like Voyager, into a dark opening is impossible because anything entering the event horizon is pulled towards the singularity, where it is compressed into an infinitely small point. So, you can't exactly spend billions of dollars just to get a glimpse because the moment the probe gets close enough, it will be crushed into nothingness. Due to this obvious issue, scientists are left with no choice but to study these objects in a two-dimensional manner, even though they are three-dimensional phenomena. To make matters even more difficult, there are also the two issues of every dark opening being unique and the laws of physics as we know them breaking down when we try to explore the inside. This means that the conventional methods of scientific inquiry don't really apply to the study of dark openings. That doesn't mean that experts haven't been busy. There are heaps of different theories and explanations about dark openings, and with each one, things get more and more interesting. One of the most compelling theories about the formation of dark openings is that they are formed from collapsed stars. When a star exhausts all its fuel, it can no longer produce enough energy to counteract the force of gravity that is constantly pulling inward. Thus, the star begins to collapse in on itself, becoming smaller and denser. If the star is large enough, this process can continue until it becomes a singularity. To understand the nature of dark openings in depth, NASA researchers turned their attention to the center of the M87 galaxy. Astronomers discovered a massive whirlpool of extremely hot hydrogen gas spinning at an astonishing rate of 1.2 million miles per hour. The sheer force of the spinning disk of gas should have caused it to fly apart in all directions. Yet it didn't. Researchers concluded that there must be an enormous mass accumulated at the center of the galaxy to prevent this from happening. This massive object weighed as much as 2 to 3 billion suns and had to be a dark opening. But that's not the only theory about dark opening spin. In 1963, New Zealand mathematician Roy Kerr used Einstein's equations of gravity to provide the best description of a spinning dark opening. He showed that a spinning dark opening wouldn't collapse into a point as previously thought, but into a ring of fire or a thin disk. The disk would spin so quickly that centrifugal forces would prevent it from collapsing. This spinning disk of matter is known as the ergosphere, and it's the region surrounding the dark opening where the laws of physics begin to break down. However, the most intriguing aspect of Kerr's solution was that it predicted the existence of an Einstein-Rosen bridge, also called a wormhole. This theoretical passage through spacetime connects two separate regions of the universe or even parallel universes. The idea is that if one were to fall into a dark opening, instead of being crushed to nothingness, one would be sucked down a tunnel through the ring of fire and shot out of a white opening in a parallel universe. To grasp how this works, we need to look at the concept of spacetime in Einstein's theory. In Einstein's theory, objects with mass warp this fabric, creating a gravitational field that causes other objects to move toward them. Now, imagine a piece of paper representing spacetime. If you place points on the paper and draw a line between them, that represents how objects move through spacetime. But what if you could fold the paper in half and create a shortcut between the 2 points? That's the basic idea behind a wormhole. It's a shortcut through spacetime that connects 2 distant points instantly. Wormholes aren't just a science fiction idea. They're actually a prediction of general relativity, although no one has ever directly observed one. The reason is that wormholes are inherently unstable and would collapse almost instantly. However, the existence of an Einstein-Rosen bridge could mean that dark openings are not just cosmic vacuum cleaners but could also be gateways to other regions of spacetime. So, could we use a wormhole to travel through space and time? Unfortunately, the answer is likely no, at least not yet. Even if we could stabilize a wormhole, it's unlikely that we could use it to travel through time. The energy required to do so would be astronomical, and we don't have the technology to harness that kind of power. But the idea that dark openings could be more than just cosmic garbage disposals is tantalizing and opens up a world of possibilities. Now, let's talk about what is inside a dark opening. There are many theories about what lies at the core of a dark opening. Some scientists believe that it's a singularity, a point of infinite density where the laws of physics break down. Others believe that dark openings are connected to other universes or dimensions. But one thing is for sure: whatever is inside a dark opening is beyond our comprehension. We simply don't have the tools or the knowledge to understand what's happening in there. In the end, dark openings remain one of the greatest mysteries of the universe. They challenge our understanding of space and time and force us to confront the limits of our knowledge. While we may never fully understand them, we can continue to study them and learn more about the nature of the universe. And who knows? Maybe one day we'll be able to travel through a wormhole and explore the mysteries of the cosmos firsthand.